This video presents the features of the Volucalc RT. Hello, this is Benoit Baudouin. I'm the president of Made Labs. I will be presenting the Volucalc RT. So to get there, go on the website madelabs.com. When you get there, you will see this, and to access the product description, click on the icon here on the left hand side, and you'll get to the description of the Volucalc. So of course you can download the product description, and it will show you different things about what that product is, and some specifications and the accuracy and some of the reports that you can get without any need of software. But that's not my goal here right now. I want to show this to you in 3D. And by the way, if at the end of the presentation you really like it and you would like to specify the product, of course you can get the engineering specifications. If you would need these specifications in a Word format, simply email me. My contact information is right at the end here on our website. So we'll be presenting the Volucalc. So I'll just click on the Volucalc here, and I will open this file. I will open here, and here we'll be presenting the Volucalc. Here we have it. First, I will make sure that it's not distorted, so it makes more sense this way. The Volucalc is quite a small product. As you can see, it's not even the size of a pen. The Volucalc is configured using a configurator software, which is supplied free of charge with the instrument. Of course, you can download the most recent version of on our website. Just have to create a configuration file that you copy to a USB drive. You put the USB drive inside the instrument, and the instrument will update itself. That's how we also upgrade the firmware inside the instrument, and how you can upload to the USB drive different reports, a monthly report and overflow reports, event reports, that kind of stuff. So also, if you have a communications device connected to the Ethernet port on the instrument, then like a cellular modem, a Wi-Fi modem, or if the instrument is connected directly to a device that allows internet communication or intranet communication, then you will be able to upload to the free SCADA software Made Maps the data from the instrument, and you will be able to upload using the same system a new configuration, so you can change the configuration remotely, and you can also upload a new firmware remotely in this instrument without having to reload the configuration file. So the USB is very practical. Of course, on the display you'll have a lot of information which change from time to time based on the version of the firmware that is inside the instrument, so I won't talk on it really, but you have a lot of information on the screen or through the different buttons. By the way, the bottom row of the screen is always the context at which you can use the 4 key that you have here. So in the default menu, in the default screen, what you have is key 1 is for the menu, key 2 is to go in the real-time screen, 3 is to get more information about what's going on with the instrument, and 4 it's anything related to the USB drive, like I was saying before. So if we look at the connectors, okay, let's go there, and let's hide that pen. By the way, I can hide. Here is it. Okay, so what I have with this connector, okay, so I use a 12 to 24 volt DC power supply to power the instrument. So and we'll always use a CSA or UL approved power supply, of course. If you want the instrument to be used as a UPS to power up some 12 volt equipment like a modem or a ultrasonic sensor, for example, then you can connect a gel cell battery, and the Volucalc will keep the gel cell battery powered, and if you have a power failure, then it will use the power from the gel cell battery to power itself and to power whatever equipment you had connected to it. You can also use the relays that are here to power up the equipment only as needed. So if you would have a very long power failure and you would not like to have the modems draining all the juice for nothing, but only when communication is required, then the instrument would just close the relay in order to power the modem until it get the communication. Then it will reopen the relay after the communication is being successful. If you have a rain gauge, you can connect it here. It can be used also to record other things like a high-level float, intrusion, other things like these. The pressure sensor, all the analog inputs of this instrument, and there are 6 of them, pressure, level, and each of the P's here for each of the pumps. These can be set to record anything that is analog, that is in the format 4 to 20, 0 to 5 volt, 0 to 10 volt, or 0 to 24 volt. So if the pressure sensor is not used for pressure, which is just the default usage that you see here, then it could be used for something else. For example, if you already have a flow meter there and you would like to record the flow or use that flow as the primary flow, and then the instrument would have to adjust its own flow based on that, you can do it this way. If you want to record something else, you can do it also. The level input can be used for level, of course, or something else. When it's used for level, and it's in the lift station, of course, then you only need to enter the area of the well into the configuration software in order to calculate flow rate. So, and also, flow will be calculated if it's for constant speed pumps. Flow will be calculated every 30 seconds or every 3 inches, whatever comes first. So you get real-time flow out of that. In reality, the instrument is reading the level 40 times per second, make an average, and to be able to compensate for the different waves that you might have in the level. So in order to calculate a most accurate flow rate as possible. Once it's calculating the flow rate, then it will use the flow out here, which is a 4 to 20 milliamp outflow, that will be readjusted every time a flow is calculated. So if there's no level input connected to the Volucalc and it's only using the pump start and pump stop to determine the level at which the pumps are, then it will calculate the flow only once per cycle and or twice per cycle on the rise and fall of the level. Then it will readjust that outflow only twice a cycle. And relays can also be used to generate alarms. So if there's anything that is abnormal that is being detected by the instrument, things like, let's say that we're monitoring the level and the level went lower than the stop level. Let's say that we would have a siphon effect. But you might want to generate an alarm. If it's not sent remotely by the Volucalc itself, maybe you would simply want to close a relay to turn on a light or something like this to say that there's something abnormal. What kind of abnormal behavior the instrument can detect? Let's say that the pumps do not alternate like the way they use. The pump capacity is not the way they are using. They used to be. The runtime is completely abnormal, or the efficiency of the pump, the number of gallons pumped per watt of electricity, is not what it was before. I mean, all these things are abnormal behavior in the lift station. And since the Volucalc is a behavior analysis system, then it will generate alarms based on that. Most of the alarms can be sent to MaidMap, which in return will send an email, okay, to the people that are responsible to take care of it, and so that they can acknowledge about what's going on there. If it's used for variable speed pumps, then of course the level almost always there. Pressure, it would be the pressure of the force main, and that's a way to calculate the head. And since we're using the pump curves that are readjusted for the reality of that lift station and the real head to calculate the most probable flow rate through the lift station, then it's important to have those. But they are not as important as getting the RPM from the drives. In this system, it's on the top here that we connect the pumps. So, and we have some small dip switches right here. These switches are placed on the left hand side, as you can see here, if the current sensors are 75 amps. And the kind of sensors I'm talking about here, we're talking about sensors like this one here. That sensor can be set for 15 or 75 amps. And it's a very small sensor. That's what it looks like. Okay. So I would adjust that switch here to 75 or 15 amps based on my requirement. Most of the time 75 amps will do the job. But if you need a bigger current clamp, or if the input is not used and you want to use it to monitor something else, you might want to use a bigger current clamp like this one. And in this case, it's you would need to put the switch to alternate. In this case, alternate would be on the right hand side. Also, if you're not using one of the pump inputs, then you can use it as 4020, 0 to 5, 0 to 10, or 0 to 24 volt inputs. If the inputs are used for variable speed pumps, for example, if you have two variable speed pumps, you will connect the RPM coming from the drives on for pump 1 on input 1 and for pump 2 on input 2. And then after that, you will use the current of pump 1, one of the phase, connecting to pump 3. And for pump 2, you will connect it to pump 4. Okay, and in the case of the RPMs, since these are not 15 amp or 75 amps, they all alternate. Therefore, the switch, in the case of pump 1 and pump 2, will have to be moved to the right-hand side here. For a typical constant speed pump lift station with two pumps, you install two current clamps connected to pump 1 and pump 2, and the instrument is installed. That's it. So, but if you want to do something more, you can, of course. On the left-hand side, you have relays related to each pump. On a typical lift station, when the pumps alternate, the worst of the pumps is the one that will usually have the higher run time. That means you're using more of your worst pump and less of your best pump, and it's always the case. And because you're doing this, you're wasting money, electrical money. So that means the electrical bill are bigger than what they should. Most of the time we want to try to wear the pumps as long as possible. I think the idea would be to use more of the best pump and less of the worst pump. The relays here can be used to indicate to your controller which pump should start next in order to save money. So in the software, it is possible to tell the controller by closing the relay before you reach the start level, which should be the next pump to start. So when the flow rate is high, let's use the best pump. And when the flow rate is low, during the middle of the night, for example, let's use the worst pump. This way, people will be saving money right away. Also, if at some point you reach a level like the lag level and no pumps are on, it means that the controller is not controlling anymore. Something's wrong. The instrument here could be closing one of its relay. It could transfer the control of the pumps from this controller to itself and then close and open its pump relays according to the levels at which the controller was operating the pumps before. So the Volucalc is able to be used as a backup controller to replicate whatever the controller was doing before in case it stopped doing it. And we do have this port here, expansion port. That's a CAN bus port. We have not finished programming all the usage will be doing with it. What I forgot to mention is if you put a USB drive in it, here's what you will get. Made maps, and yet let's use a password 1 2 3 4 5 6, and I want to remember this, and let's log on. So if I look at what I have here, this is real-time stuff going on in Miami. So if I click here, I'll have an idea of what was their flow rate in the last hour, and if I want more detail, I can go there and see what kind of flow rate they had here during that period of time. So that's what I have here, and I can look at what it looks like for the last 7 days. And they had some nice big spark here at some point, and really odd behavior here also. So anyway, that's what Made Maps is all about, but I want to show you a reports instead. So I'll just go to reports, device reports, and these are the reports that you would get if you would put a USB drive in the instrument. That's exactly the same file. Okay, and let's zoom in. And if you would copy this to Excel, it would give you something like this. It would be all pre-formatted in color and everything if you copy it to Excel. Okay, that's why we have selected an HTML format. Okay, so what you have in there, you have an idea of where the instrument came from and the dimension of the well, the cost of the kilowatts, and the hour meters that we had on them, the power consumption that we did, and the cost of using this lift station, these pumps. Then after that, you have for each day of the month, and in bold, you can see which ones are Saturdays and Sundays. You have the efficiency in gallons per watt of electricity of the lift station, the efficiency lost, how many kilowatts have been lost due to inefficient pump here, the percentage of use of the station, which is quite high, the maximum level that was reached. If we had the rain gauge attached to it, you would see it. Total volume that went through that lift station, the average flow rate we had in MGD in this case here, the minimum flow rate when we had it, and maximum flow rate when we had it. And of course, at the bottom, we do have the totals and averages for the month. And now for the pumps. Again, we have, let's go and select a pump that was working. Okay, here we have a 125 start for pump 1. That pump ran a lot with others, okay, 21 hours, okay, with others, and runtime alone only 1 hour, so 20 hours of runtime during that day. I mean, that is completely abnormal. Current average, the average current, I mean, total outflow that we had from that pump, and the efficiency and the capacity of the pump. So this is the total volume that we had that went through that pump. And of course we have totals for the month again, and we have the same thing for pump 3. And of course we do have these things for combination of pumps. And in this case we know that pump 2 and 3 work together 19 hours 41 minutes on that day, and they work together 128 times, so it's quite a lot, okay? And we have an idea of the capacity of the combination of pumps. And then we have it for the other combination, and at the end we have these abnormal behavior that has been detected by the instrument. So when you look at it, you can go and look at the details of what happened. Okay, so this is one of the reports that you get simply by putting a USB drive inside the instrument, or by downloading through MadeMap. Okay, if you want to install the Volucalc on a panel, that's what it would look like. Okay, there's a bezel that we have made for it so that you can just drill a hole there and fix it this way. Okay, also if you want to install it on a DIN rail instead, we have these little things here that we have made so that you can screw it there and clip it there, and to unscrew it, wait a minute, I'll just change this to that it's easier to see. You just need to put a screwdriver there and push it, and that will unlock the brackets that allow you to clip the Volucalc on a DIN rail. Also, if you want to have Volucalc inside a watertight control panel, here we have a Pelican case, in which in this case we do have a modem in it, and let's use one of the features that we have in with this software here. Let's make transparent. So, or even hide. Let's hide it. It will be even better. Okay. So what we have here, we have a door that completely opens so that if you want to connect anything, it will be easy. If you want to put a battery backup in it, here we have the space that would be used by the battery backup. Here's a modem that we have put inside this instrument below the instrument. So basically, when someone buys this package, this kit, you have something that is very, very small, because as you can see, it's just slightly bigger than the instrument itself. So it is small. Reset. Here it is. Okay. So if you want to install it, you have the possibility of screwing through these legs here so that it fixed right behind on a cabinet on anything really if you want to. So there's no real brackets required to do that. And the bottom part and right hand side here, mostly bottom, is big enough to fit. Let's put this transparent here. It's big enough so that you can put connectors there. Okay, I think that concludes it. And if you need any kind of pricing, please contact your rep about that. And I think that covers it. If you have any questions, please don't hesitate to call me. So my name is Benoit Baudouin. Thank you.